Interesting sharps. Interesting. Well, I'm playing with some droids and things out here this morning. Really running the book. Again, it's all the book model inside of here. What do we got on YouTube? Nothing special. I'll get rid of that. We'll need that later for this. All this, what we're about to do. I think I put one out here about Squiddy. We've been running this setup right here. You can play with some stuff. I haven't quite figured out the video into there yet, but that might be interesting later on because I want to do some of that 3D graphic, or well, 2D graphic in the 3D multiverse about running some of that stuff that they do on YouTube that we've been clicking on these buttons. You know, the drawing on stuff, the little numbers and letters on lines and ones and zeros. And then we actually graph those out. We're going to go ahead and do them a few different ways. There's several different math problems. Strip it all down to general relativity on the stone mill and find out you pop out a neutrino like the 401k mountain. It's fun. It's fun. Yeah, ways to track that is not this. I know this seems like an interesting tool, but back to Droid. Go back to Droid here for a minute. These lines and graphs, they're pretty quick. These can be as quick. Tom, quit clicking. Go away. Go away, Tom. You're clicking stuff, but you need a straight edge. But if you're fast enough with it by hand, I'm a little faster by hand than obviously I'm with the computer at this moment, then I still want to beneficially the monopole list inside of here, the Hutter's prize or whatever, or Rhodes conjecture. Depending on which version of the internet you go through, which cabinet over here as you do. No, you don't say that. It's Kyle things. We go in Kyle box with that. You delete that droid. Click. Snap. Hide it. It's Kyle's thing. You don't do those. Not I would know. Anyways, so you post it, and then yeah, you do things with it. Well, it gives you clickbait, gives you YouTube, gives you this. Somebody types in your name, you're all over the internet doing some stuff about inline topology, about kind of these systems right here. It gives me a chance to hook up on that. All right, I don't need Salty 1. I've seen the code before. Oh, this went to 7. AR, or it was like ER, 8006, yeah, something like that on. Interesting. Because it pops up over here. It's in this box now. Which is this box on the floor, which again, your 401k. And the model's the box. Negative and positive. Negative calc. You ever seen negative physics before on the thumbnail floor? Somebody's job. That's what they do. They just watch a team of units go, and they this one's got lint on it. It's not using the flag right, and now a drill sergeant doesn't get it. Interesting. Interesting. Ones and zeros. Which button does it? You click on this, and then this thing takes you for a ride on this for a while. And just happen along, going along. Is he gone? Oh, is he gone? I say ride with it until you get it. And then you start arguing with them. Well, sharps. You come in here, Salty number 2. He did it like this, and it just does this. Damn it. Click. That's how you do that with the stone mill, huh? That's what happens, and when that happens, you'll do this, and then those things will happen, and this blink, it'll go over here and camp out in this one for a little while, and that'll be you. How do I know? Because calculus. Calculus is you. You are calculus. You are field theory equation. Shadow. Tom, come here, Tom. Explain this to these people. Okay, go away, Tom. Is it an app? Is it a click on a button for a file that pops up into the... Sure. Yeah. Talk about this guy right here. Bring up the name of some devil. Oppenheimer. I'm juggling here. Interesting. Well, there's lots of ways to do it. Me, there's so many things where I get G-locked a lot of times. Is, the clicking. How do you know what to click? Because you'll just be sitting here drilled and I hate it. I can't get past this step. Yeah, hit more buttons. You're reading a bunch of it and you'll get into this next one. And you'll just fall into the void at that point in time. You just, Alright. And then you'll realize you need some other stuff. Get one of these other ones up here. Whatever this one is here. This one's one of the droids I got going. And so I don't have to, I just want to click, instead of having to type that all over, go through fucking Homeworld every time so I have it memorized in my brain verbatim. Go away, Tom. Well, they're one of them. They give you these kind of, where have you seen all of this before? I mean, where have you seen all this before? Given samples. Remember, if I didn't just make that disappear, where'd it go? Let me come back. Sample. Virology, this little beaker right here. We're letting it grow. There's some green ones, a little yellow one over here. Blue, purple, whatever. It's observation, IH, smallest number, blue, purple. There's a difference. Spectrums are more relative to the signal in the alien spacecraft there. Nick. Keep up, Nick. Come on. NASA's 11 Bola. That's where they got you. Fuckers. If I walk over there right now and we do this in there, and it's a problem. It's like, oh, why don't the senator right here? This is fucking why. They do it in their schools now. I don't know which grade. We can make that. We can do things. I'm up for debate. There's a lot of answers here that make it the Rarity standard model. What I would be like, that's a cool one. I made a nice little droid bot with that that's benevolent and a little malevolent. He'll come at you, boy. One of them. This one. Oh, they're coming at me. Evading the primer.
Today we are going to talk about recursion. I think most computer science students would agree that recursion felt more confusing than your average computer science
Where'd you go,
topic.
droid?
In this video, I'm going to show you 5 simple steps
Ready?
that you can use to help you.
Guess what happened the first time they tried to do this? It exploded. It was on this one here and the ones and zeros, not where it was supposed to be.
I'm going to show you how to apply these steps in the context of solving 3 specific recursive problems, each of them progressively more difficult than the last. So make sure you stick to the end.
You don't know anything. It's like watching the bit guy or some computer engineer go through. What do you got? Microsoft's Homeworld file cabinets over here. This is the literal dude coming through. He is just. All right, wait, cancel. No, I got a better one. Alright, so this is that guy. There's the towers and servos, cooler station. They got a water cooler over here, lunch station down here. The secretary around here somewhere.
Here's a couple quick examples of inputs to this function to give you a sense.
Right to the first one, I bet. Bang. This is the gold standard, by the way. This one. How do I know? Because it's in the fucking unified field theory.
Next generation wheeled excavator provides enhanced comfort and
actual point. Honestly, I hope I explained this well enough for you guys. I did my very best to actually lay things out for you guys, point blank.
We were doing that, remember? Imposter, where I was like, this is the first person shooter, this is.
And you're done the
this is YouTube. You want to know how to YouTube? Be a better YouTuber. I'm chugging right along.
If you're actually watching this for some other reason, and you're just wanting to figure out how to do land nav like the way the military does it, then this video should, basically show you guys it. So I literally walk you guys step by step with actually paying attention to the map.
Right down and dirty. AK-47 in the mud. Click land nav. What do you do? Shake it first, and then you go. You didn't. You clicked this button wrong, Tom. Explain this to them.
Plot your coordinates, figure out your azimuth, figure out your distance, and then actually go to the points of the
do this and do some math.
About everything in this video, and maybe it would have been a good idea to split it up, but again, numbers and times and stuff are down in the description below. So if this video ends up being beneficial to you guys, I hope you hit that like button. If you want to stick around for some more videos related to the Army, basic training, AIT, what it's like, different. So.
Okay. See the sneaky thing? You see that sneaky son of a bitch pop up on you, looking at you, blinking at you? Yeah, you do now. That's right, you do. This, where am I? Make sure I get this in frame. Here we go. I'll give you that person-to-person contact here. That's this. That's this little guy right here. See him? See the same page on the screen? Just real little. Real little. The beauty on that is it's also this, because it's that. You're doing this in lensing, and you don't know anywhere in the universe where you are. The scale, it needs things about gravity down here. You'll need these things. The angle off the magnetic and true north, because Skull Rock is over here, and that's your new north. That's bipolar 1s and 0s. You know, you're going to go in that direction from here. If you're in this area next to that thing, guess where north is? It's over there. Now it's over there. And that thing from the Andromeda paradox of a tree here and a tree here, and this person walking with an imaginary line here, and then this person walking relatively from it, guess what? They're not the same thing. But if you were using the location, true, very true, from there you're going to go north. If we're here, that means you're there. You do -1 left in that direction, and you go. You're there. Got it. How do I know? You just walk in that direction until you either hit that or something else, and walk off the edge of the earth. Start again. Interesting. How do I know? How do I know?
Experience matters. For over 145 years, more families trust ADT for timeless protection and 24/7.
And his ass is in the unified field theory. I got him in the Pokeball too.
The #1 home security provider.
Matrix. Well, my first Matrix is literally a goddamn Matrix.
We were the first to bring 5G nationwide. And now that Sprint is a part of T-Mobile, we're turning up the
Well, maybe you cut out the Matrix, you leave the composition and the triple point, and you take out the standard model, and that gives you 3 or 4. Minus the Matrix and the standard model. Maybe you do all 3 of them. Maybe you skip one of them and you do the other.
Who says you can't have it all?
It's a wire. It's connected. It's all squished in
This
there.
video is sponsored by Dashlane. Circuits and electronics, image processing.
Well, this is what I want in the class. I don't care what the fucking grade. I want you to come at me in my class and be like, this is my business boss. And fuck out of here, I believe. I got all this stuff going. Small business models, application, bullpit patent designs. I'm taking Normandy with blow-up tanks. We're doing it. Again, we'll just walk over there and blow up tanks and make money with it. We'll make a big show out of it and fucking pull the 1s and 0s around.
Now, in the beginning, matrices can be one of the most boring subjects we learn.
Well, the problem, Joe.
Maybe not for everyone, but at least that's how it was.
Scout guy.
I mean,
It's not me. You can't be salty and be the scout.
Just set the corresponding entries, and you have your answer. Then multiplying a matrix by a single number is as simple as multiplying every entry by that value.
If you do this process, see, very fast. Very fast. Let's get my squigglies on here. I could probably figure it out with Squibby here or Google Class. You do stuff. Do stuff here with Google Class. Where this one. Just click on that real quickly. Inside of here, we can make a new classroom, or we can go to the classroom we already got on stuff. And we just make new assignments on things. No, I'll do classwork. I'll do everything in here. I'll put a video in there. I'll figure it out. We'll do stuff. It'll blink. It'll run. Yeah. Raise you from the dead. Just interesting. This guy probably do it, light you up and give you a little zap. You got to get the Hydron Collider right. If you just use it to make a Nokia phone radioactive, it doesn't do a lot of good. Yeah. Yes, right here. It's not a million steps beyond.
And we do this weird row by column dot product multiplication, which
Beat me
some
to it.
teachers just give no context to. So yeah, this isn't the kind of stuff that makes you want to major in matrix math anytime soon. I mean, you might learn more.
Well, where's the gun? Where's the freedom to assembly, right to bear arms? This guy and that guy. If you get this guy together and they're doing this, and you're like, you do this, I'm gonna do this one over here. We're gonna both do good here. I'm really not quantifying you to make any less than what you thought was right about. You sure? Because you can do shit if I put you in.
More in high school, but overall, a lot of it just isn't that exciting. However, I promise matrices are used way more than you probably think.
Little ball.
But the first thing we need
I
to
can touch
realize
it.
is that matrices do things to vectors. Don't take this as a definition, because it's obviously not. But we do need to see what happens when we multiply a matrix by a vector. For example, a vector that starts at the origin and ends...
Well, a vector isn't really X, Y, or Z, but I am a vector. I'm a tangent, I'm a a mean, I'm a mode, they're all X, Y's, and Z's in that operation. It is a vector. It's an avenue on the type of things in zeros and ones. And so all of the zeros, like and one half of it, is just like, no, I don't want to be in that part of the screen anymore. And you can't make me. I'm going to have to do 4 zeros in here, and it's going to have to figure it out. And you're going to have to do stuff because it'll be weird. You would just think like, oh, well, 1 and 7 in here by grid points of the pixels of hello world on this little screen. But no, none of those things yet. You didn't make it. Somebody gave you this thing, and you're like, hook up this wires. All right, cool. In the same game, but the blinkies go somewhere else. They go, I don't have somewhere else. And this means this, and then it's in here, and it bangs around for a while, and then you float around. Vector. Gone.
Ends at 1, 1 can be written in matrix form as shown. X component on the top and Y component on the bottom. And when you multiply by a 2 by 2 matrix like this, through the
So, well, when you multiply 2 by 2 like that, you're usually looking at it from my perspective against somebody like him, because he's already got this on the internet now. He's got 1 million views. That's math. I could graph that. I could say over time since October and just use that analysis of it. And that gives me this, and just pure math. And essentially pure math, but he's throwing in a math problem like, well, it's not really that they're whole numbers in this form. There's a process of steps that make those numbers what they are. And if you know that the name of matrixing is not the Big Bang or somebody looking at a fucking rock. It's it put here and it just kind of pulls this way, whether it be wind or whether it be system. Then that all became part of the field as a vector. I had it in the box and I put 1 wind on it. And if that's in the standard model of north and zeros and ones, because I'll orientate, I'll fucking bolt it to the table. You wouldn't think, but then you got batteries and wires and just the whole thing. 1, 0. So these are ones, and they can be quantified. 0, 1, 0, X, Y, Z time. You could go, that's a matrix. Because this will do this. See, 1, 2, 3 in numbers. Sneaky. But if you got the organization of the geometry by Bell's equality and general relativity satisfaction of field theory equation, you'd come out like this. And it wouldn't matter if you had an accent, you're an asshole talking about somebody robbing Zach. I got the kidnapper. I want the money. I don't know who you're talking about. I don't have those people. Well, can I just give them to you? What? All right, yeah, you know what? We'll just make you a business. Just bring them to me. They probably need computer training. Anyways, I would go to his computer training. He comes to me for the stone mill for workers' numbers, not because I'm going to grind him. Nancy Pelosi in the stone mill, she'll make it. But, yeah, if I said that number and FM made a vector inside, yeah, all right. Okay, go on.
The multiplication rules, we get a new vector out, in this case of 1, 3. So we put a vector in.
You need these fucking steps for some dumb shit like me trying to be Droid. That's what you need to do it for. After the point that they're making stuff and then you get them in the stone mill, they can assembly line something so I can general relativity. I can get them anyway.
Now, some matrices are much simpler. Like this one here.
You put it together like that. Yeah, exactly like that. That was the MSO. We all believe in it.
And out will come the same vector, rotated 90 degrees counterclockwise. This matrix, on the other hand, will just scale. Any vector that goes in comes out twice as long. But most 2 by 2 matrices like this one we were analyzing aren't as simple. Different input vectors, I'll just put a few here as an example, get scaled and rotated differently. However, the transformations are all linear. As in any
send it like every time we go on YouTube right now. You do something
to a vector on the same line as the corresponding outputs. These linear transformations are why we called the first in-depth class on matrices linear algebra. Anyways, I'm going to redo those transformations once more, but this time pay attention to this vector here.
You see it?
You'll notice it's the only one that is just scaled. It doesn't rotate at all. And this would happen to any vector on that same line because of what we just saw.
It's good. Yeah, I love Fox. I love it. CNVC especially. I mean, these are hard numbers to get. If you're good for law, it's obvious. Like, I've tried it law. Cases, evaluations, journalistic reporting, or integrity. That's the integrity of the term.
The last thing to mention is that
Bell's equality. We satisfy... crack. You know, you don't even understand how dead you are. You even see it today in MIT by the classroom. Fuck the chalkboard. What's going on in the room? Math, vectors, so I got to put them all on a list and then do things like app, period, create shit. Because I got the standard model on Snowflake and they 0, 1, 0, 1. So you take the 1 and the 0, which means 2, and you put it up above fucking 10 or 8 or 7 or 9. Ooh, I don't know. Maybe it made sense because these numbers pulled together. And in the process, you can find doing that. I said, as you go back to Droid, go to your Droid right now. And you get in here about, all right, so I'm going to fucking burn all of these right here. Well, not salty 0. You go, maybe now you do things? Why would you do that? I don't know. So we want those. I want to save those for make sure we don't break them. Alright, so yeah, basic steps. I can't undo that. Again, that's the little step inside of there about just ripping it down because it is not regular Droid Homeworld. And I can't go back and show you that. You're going to do that. Like, you'll be sitting here, I wonder what that first home, was it worth the position on the button? And you click in, it's like always there. And then you find out some 0. Well, that's the problem. Why does it keep moving around? Because you ain't got the 0 right. You ain't got this 0 right. Marshmallow, by letters, will not obey the rules of the universe. And he'll do what the fuck he wants. And he'll pop up over here. Why did you do that? Well, you better try a 0 in front of that next time. Because it'll be a very simple set, or a Z. I think this one, I had a Z in there. Because I know it's going to be the last one. So no matter what I do in the order, as long as it obeys those rules on that scale to this line over here, it'll always do that. And I don't have to worry about it. Click, click, and then it'll just thinking about the name of the title. Where is it going to be? Click. It's going to be right there. And you get that way. I mean, it gets that way in the stone mill. You know, I've done a lot of stone mills and all that, so it gives you a lot of manufacturing on parallels. Just N1/2. I'm subtracting land navigation from this center margin right here. This is kind of when I say I'm in the stone mill. I got to tread. It's going to be a chess game here in a minute, you know. Remember, we're looking for Hubble's constant. I think that's the first bit. I didn't tell you what this is. I didn't tell you. I left the problem on the first page. I know what that is. I don't have a problem with scale like that when somebody's coming at you like that. Hubble's constant, that's right, you know, and so you get in there, standard model, strong force, weak force. Is it a strong force right now? Is this the thing that matters so much into it? But if it needed to be this, it fucking mattered, though. You know, and that's electromagnetism to motors and stuff. Without that number turning this action, click, 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 Xenon paradoxes and stuff like that, Z-balls on. So, get back to thermal and rock. Inside of here. Interesting. And yeah, so Pensrow does that. New standard model. Kind of got the Nobel Peace Prize 2020. You know, what am I doing with Pensrow? What is lensing? What is, you know, lensing Einstein cross inside here? It blinked up there, blinked down there, and blinked down. They're vectors. It's not neutrinos or supernovas. They're vectors, blinks in zeros. Blink, and you're just in the stone mill and that hose blinked at you. What do you mean the fucking hose blinked at you? I mean, somebody named Murphy, Tony, Purgatoni, you come with the fucking equipment, brother. Yeah, and I'm the garden hose. I'm gonna beat you with that garden hose. Because I wasn't fucking free-thinking dude named Larry. You owned like a fucking horse. I was a vector position, right? Why, I'm glowing right now and you fucking feel me. Good kitty. Well, over time, click, 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 click. Samples. What can you do? Well, you go on the stall mill and click 1 day, 2 day, 3 day, and you get the exact same number of buckets every day. They keep dumping them in on you. It's pretty consistent. It's concise, actually. Matter of fact, on that chess game, it's going to come up later time. How long? Well, any questions on stock models of job security, whether this is the most valuable thing in the court case of the work fraud and your management. I mean, did you try Tomcat that far? Try him over here. Well, that's quantifiable word superposition, so are you. Like, I think icon's a word. It means vector. I think I'll do it for a while, maybe. Maybe I do it at times. And polarizing wave function. Where are you? Where are you, buddy? You got the one I want in here? Well, you can use one of these. There we go. Heat equation. I know this is partial differential, but we can use it. It's the same stuff. What we got on the island? Heat equation. Thank you. A little flag for you.
It's the same wave. It's just shifted in phase by a quarter of the period, which would make it
interesting.
As we want.
Very interesting.
The second derivative of cosine of x is also negative 1 times itself.
You saw it.
Cosine of x times e to the negative.
So, how do you do that on a paper? I'm glad you asked.
Atoms in an old bone changes is all, say, 0.
Where are you? Go back.
That negative constant times t times.
You should watch this several times. Which one do I want to use? We could use this one. That's a good one. That's a good one. We could just use the whole stone mill. It was right there by the saw. That's A. That's not this. It depends. Later on, he'll get why the waves aren't all the same smoothie. It's more like a topology, bumpy little thing, and then you'll get into time dilation of you having to walk up a hill instead of just being gravity. I mean, the approximation may be so fine that it doesn't matter, but you basically felt like you climbed Everest comparatively to this one. You were pissed about it because some model on the stone mill floor. It matters. Heat matters. Heat is matter. It's a part of matter, and therefore it matters. Coming down the pipes of the Hadron Collider. I don't know. We got that one from Google this morning. Where'd you go? And there was one on Google from my cell phone. He slid it over into the black hole, and it had the little heat equation things, just bubbly, globular. That's a STEM problem. We can talk about that one. You can talk about that one like it's this one. Axioms are just square on a flat surface here. I programmed it that way. This one's got an angle with it, and you're traveling up that portion of a cell variable on E alpha time. It's telling you what the hell is up. Dead alpha time? Well, you could say omega. Usually I go omega, but Euler's number. If you ain't the fucking mathematician, he might as well be the devil or the dead on the floor. You're killing everybody. Those ones didn't get it. You got it, boss. I'm on. You could. There's other ways in which to do the Doomslayer. Come in, parachute, pack it, come in here, we'll hop on this line and this line. We'll do both of them. I'll make room do what I want. The really good one is, probably this is my better one for it. It's this stone mill. Well, they're on an axis. This flat axis right here. And then the rest of it's kind of built on a tangent line. Well, excuse me. A tangent line. And so it's all kind of shifted. And when you do that, you get a special polarization. It kind of reduces a lot of the other calculation. And I wanted to do that, not cellophane. It would be a set of, I did that because it gives me perspective of 3 guys, all the stations, the scal, and the skid steer, but I couldn't figure out the clean version of a skid steer clip art, right? So I put it on an axis, and what that do? It puts a little bubbling gravity in that spot. It gives it more irrational observations. It makes it look more complete, even though it's in a derivative T over derivative T equal, you could say. Well, it could be a gamma. It could be, I forget which one's which. That looks like I think gamma looks like an L in Greek. But yeah, so that's just the code language. And when you get into code, very good coder, but I can't speak Mexican, right? I can do it on the stone mill floor. We need 2x2s on the run. Bang. In heat equation, this went up in the ones and zeros, 1, 0, 1, 0, 1. And then we're out, E4, right? Bang. If it was us in the local topology, because we had that stacked up, then right to the singularity, right? It's just going to bang, go. That number to the setup was there. All the calculus points on an autonomous build for it kind of just Penrose. And so you get into it, and that's time xt. Well, what's xt? Xt is this book. How long does it take you to make it? That capital form of whatever the Reaper is, right? This chess game, because you might like this if he had a different model and needed to do different ones against different people. Oh, well, that's chess. Well, I got this one for you, fucker. How about now? That's it. Well, it could be Prometheus. Later on, you find out stuff about Zeus and the same team, and then there's both relative perspectives on what if the one that they won? What if they got it together? Later on, the Ring come up to a story, chained out his thing, ate his thing, his kid comes around, fucking frees him up, they get him married, fucking, That day at the story on the stone mill, it was legend forever. Heat equation. You go back as a psychologist in there, and you're just some new... I know this. What's it mean? That means you draw the stone mill floor right there, and Larry's gonna fucking bang around in there. What else you got, sir? So this is on the end of these things. Go back. You'll get into a part where this equation, well, it doesn't just uniformly do shit. So this little bubble, you remember the bubbles on the Hadron Collider? This is when Fermilab's in there, and then trying to pack it all in here to this bit the black hole, and this is the wavy bits of the universe. And then this line is actually this, but the 3D graphic makes it a circle, and you round off the corners on this. And there's a little hole at the end of this pipe, right? So if it's a uniform length, generally between here and here, and if I didn't know the increments continued like that, but I could see 0, 1, 0, 1 on scale, I would say, great, I should. The problem is there. Why is that problem there in the approximation that I care? Well, Fermilab, they need to give a shit about that apparently, but you'll see this pipe right here, and because that temperature differential is there, different, and it has a different surface, or it has a different thing that it cools down faster or something, and by doing that, it doesn't have this clean trajectory of temperature differentials. It has a connection directly between these 2 points about, well, on time, where...
By their neighbors to the interior. In fact, let me give you an even simpler solution to the PDE, which fails to describe actual heat flow. A straight line. That is, the temperature function will be some non-zero...
A spring, yeah.
X.
You know how I test... whether you get temperature equations or not, I'm going to put a piece of metal down in front of you. And I'm going to say, how do you make this a spring? And you say, well, you change the shape of it, right? You'd say you change the shape of it, and maybe you do something to it, click, click, and then it behaves in such a way with the gear force ratios, click onto a thing where you have the numbers on a circle, flat square, that says this make that. So what if I'm in that piece of metal? What if I changed that day? What if you knew I was running in this direction and that's a spring? I was walking relative to each other, and you don't know the difference yet, but if you've seen those things, that become a piece of metal. That's that piece of metal on a squishy piece of paper. The spring. That's the temperature equation. If I had my lockpicks, I would. I have one or two of them floating around here. There you go. Tom, get out of the way. So I cracked this thing in about 3 seconds flat. Brinks ain't shit. Get out of here. Brink. Heat equation. You'd graph enough of them, enough people, you would see, So this motherfucker's trying to look in there like that, and it makes a lot of heat problems on the equations of zeros and ones when it pops up. But this one, he's like real fast about it. And then a lot of them did that, and they were all the same size box. So we use that type of metal, and that's the type of metal. And then I hit him with a wrench a bunch of times, and it makes them work faster, even that. You can see that thing like this. And anytime you didn't see it like there, somebody's like, catch you on the next one.